Well, today we're going to talk about uniform circular motion. I was going to try to do the spinning right round wrap, but then I realized that would be kind of scary. So anyways, describing the motion of objects following a circular path. That's what uniform circular motion is all about. So the vocabulary, I'm not really going to spend a lot of time on this. This is vocabulary you should have seen before this year. But if I did want to give it to you so you'd have it, so when we use this terminology in class, you'd be aware of it. I'm going to go ahead and move on, so you're probably going to want to pause it so you can just write those words down for your answers. All right, so objects move in a circle at a constant speed. That kind of makes sense because as you look at the Ferris wheel here, they're moving at a constant speed around the Ferris wheel all the way along. We'll talk about how there's actually two different types of speeds when we talk about circular motion. There's something called angular speed, something called tangential speed. All right, angular speed is what you typically think of when you're going to say they're all the same. All right, so angular speeds are equal in a circular motion. For example, you had the Ferris wheel. So whether you're on the outside in an actual little buggy, that's a buggy, or you're in kind of on a pole on the way out there, you'd be like this in a Ferris wheel. So you're going the same speed here as you are out here. Okay, so let's say you have point A and point B in the circle. You're going to be going the same angular speed, Now tangential, is going to be dependent upon where on the circle the object is. The further out, it has to cover more distance in the same time. So therefore must be traveling faster. All right, so we talked about since speed is meters per second, you're going to travel a lot further, for example, if you're B than you're A. We'll look at that again on the next slide. It'll make a little more sense too. All right, so whether it's, you could have, this could be an example of, like I said, the Ferris wheel, or it could also be an example, let's say I'm holding this right here, and I'm spinning it around, spinning it right round, if you will, over and over again. So at angular speed, they'd be the same because they're connected to each other. This could be two pieces of rock, this could be horses on a carousel, anything where they're in the same circular motion. Now tangential, once again, is different because now you're looking at that green dot. The green dot, if you just go, it would have to cover this distance compared to the blue dot covering this distance. All right, so if tangential speed, the green dot is covering more distance in the same amount of time, so it's definitely going faster. Once again, if you have meters per second, then you're going to travel more distance, so therefore this number would be greater over the same amount of time. So for example, the blue dot could have been 1 in 1 second, and the green dot could have been 2 meters in 1 second, therefore it's twice as fast. All right, just to give you an example of tangential versus angular speed. Now, a car travels clockwise, so clockwise would mean it's going this way. It's a really good arrow right there. Okay, car travels clockwise around a track at a constant speed. Draw the tangential velocity vectors at 3 different locations. So we'll have one here. It's going to go off like that. So the tangential velocity vector would show kind of where it would go if it would fall off the circle. For example, on the Ferris wheel, hopefully this never happens, but if the Ferris wheel cart was to fly off, it would fly off in that general direction. Okay, once again, I hope that doesn't happen. All right, or if we go back to the rock example we had, that would be if the rock was cut off the string, and then it's flying in that direction at that velocity. What's important to realize is the vectors are the same length, because vectors are the same length. Okay, why are they the same length? Okay, because the length is the same thing as the magnitude. So they have the same magnitude, but they're in different directions. I think that's obvious from the picture, but you better make sure we say it just in case. I think you need to write a word or two down on your piece of paper now too. Once again, they have the same magnitude because they have the same length, but they're all in different directions. Okay? when I said that. Kind of already said that, but it is part of the PowerPoint, so I got excited about making sure we had that covered. All right, now, centripetal means center seeking. Okay, we'll use that word a couple times today. Centripetal means center seeking. All right, so centripetal acceleration means acceleration that is center seeking. So it is directed towards the center. That's a basic concept that we're going to cover over and over again. Sometimes we get confused about it. If we talk about centripetal acceleration, it's towards the center. All right, so we'll also use A sub c because acceleration, centripetal acceleration, equals v squared over r, and that v is the tangential velocity. All right, an object in UCM is always accelerating. V is not constant. Okay, remember, velocity is not constant. The speed is constant. Velocity is not constant. So a car travels counterclockwise around a track at a constant speed. Actually, let's make that clockwise because my really cool drawing already has it clockwise, so we'll leave it clockwise. Now, it's important if it's center seeking, okay, we're going to have really the acceleration, centripetal acceleration or the centripetal force are both going towards the center. Now, you saw this in our fictitious gravitational lab. It's going to be perpendicular, okay, or at a right angle to each other. So centripetal acceleration and centripetal force are always towards the center of a circle, okay? So I'll remind you of that. Now we're looking at F equals ma. My goodness, I hope you remember that, okay? Well, in circular motion, A equals v squared over r, so we could say F equals mv squared over r. To make it look a little prettier, we have it on the next page. So once again, F sub c is centripetal force, mass times velocity squared, that's a tangential velocity. R is the radius, okay, the radius of a circle, that's going to be measured in meters. R is the radius. So I mentioned a while ago, there's a centripetal force, vectors be towards the center, because centripetal means center seeking. I didn't add this to your notes, but I did just remind you, we did talk about centrifugal force. That's a fictitious force and non-inertial frame of reference. So I just want to remind you of that did exist. All right, now we're going to do a couple example problems together. So the given's already here. Here's a given, there's a given. So the unknown we're looking for is going to be the speed. That's measured in meters per second. All right, so the equation we would use here is centripetal acceleration equals v squared over r. So 9.8 equals v squared over 6.37 times 10 to the 6. Multiply each side by that to get rid of it. Okay, so those cancel out. Then we end up with a pretty big number. It's about 6.24. So, oops, mark that out. 6.24 times 10 to the 8th, okay, is a rounded number, equals v squared. So we're going to square root both of those to get the speed. So v equals 7,901 meters per second. I'm not sure why it's doing this, so I'm just going to go ahead and erase it using this. But the next question, I'm going to underline the givens rather than write them down again, because I want you to realize when you have questions on a test, you don't have to always write all the givens down on the multiple choice part. You can just underline them. So there's a given there. That's going to be the mass. This 15 is the velocity. This 1.2 is the radius. So these are all things I can write down. Then unknowns here, acceleration. That'll be in meters per second squared. I don't know that. Other unknown, I'm looking for centripetal force. I don't know this, and that is measured in, any type of force is always measured in newtons. So make sure we don't forget that. Centripetal acceleration, centripetal force. Okay, so then we'll plug in our numbers there. We're going to end up using this equation first. A equals v squared over r. All right, so we have 15 squared over 1.2. So we have, which equals 225 over 1.2 which is an answer of 187.5 meters per second squared. That's a centripetal acceleration. Okay. Now we'll go back to our understanding of F equals ma. So force equals mass times acceleration. We just found the acceleration, so we can just plug that in. So F equals the mass that we found in the question was 5 times 187.5, which gives us an answer of 937.5 newtons. All right, now anytime we go over questions together, you can always feel free to pause it and see how you do. I really suggest that. So if you want to go ahead and pause it right here, just to see if you can try to figure it out yourself, that's probably a good idea. All right, so I'm just going to box them in. So 5 meters per second, that's going to be my speed there. 300 kilograms, that's going to be my mass. 4,000 newtons is my centripetal force, because we said up here it says centripetal force. All right. So then we go, our unknown we're looking for is going to be the radius in meters. All right, and as far as our equation goes, we'd use F equals m. Now b times a, but we know centripetal acceleration is v squared over r, so we'll just add that in there. But now we want to solve for the radius, so multiply both sides by r to get rid of r on that side. And then we'll divide both sides by f to get rid of f on that side. So once again, we got rid of the f there, got rid of the r there. So we'd rewrite that as r equals mv squared over f. Now some students like to plug the numbers in first, so if you want to do that, of course you could. I just wanted to show you how to do that there. So then we plug it in, r equals 300 times 5 squared, all right, divided by 4,000. So if you want to rewrite 5 squared, you can write 20 times 25 there. So we end up with 7,500 divided by 4,000, which is going to give us about 1.875. Around that to r equals 1.88 meters. All right? So there's just a little quick recap of all of that. And that's circular motion.